Hey everybody, this is Larry. This is week 5 of the Leetcode Weekly Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. And apparently, we have a premium problem, but it's one that I've done before somehow. Alright, so given a string s and an integer k, return true if s is a k palindrome. Okay, a string is k palindrome if you can transform in a palindrome by removing at most k characters from it. Okay. Hmm. That's a little bit tricky. Because not exactly quite OCA, I guess. But, okay. I mean, I think that's not that bad. It's just that it's, definitely not a easy problem. I think I think sometimes I still kind of get a little bit lazy or just forget about it. It's kind of look at the constraints, and given that n is only up to 1,000, you can kind of think about the possibilities that you can think about, which in this case would be n squared. And here for me, what would be an n squared solution look like, right? I mean, I think for me to begin with would just be a very natural dynamic programming, and which is that we are trying to define a palindrome. And what is a palindrome? Well, a palindrome is a word, like they don't really explain. They should always explain it just because, I don't know. But in any case, I do know it, so I guess that's fine. But palindrome is a word that is the same backwards and forward. And in this case, you can remove at most k characters. Actually, actually, maybe I'm wrong. Hang on. Yeah, wow. Actually, the way that I was thinking about it, I forgot about the k. But so I may not know this one, so it's going to be a little bit less explanatory unless you go a little bit forward. But I'm going to go with my initial thought process, and then we'll try to figure out how to optimize. But the way that I was thinking is that my initial thing is going to be you have a left, right, and then a K. I actually just forgot about the K when I was thinking about it, which, whoops. Well, of course, this is going to be too slow, at least on naive thought, because left can go from 0 to n, right can go from 0 to n, technically left to n, but let's just say 0 to n in the total range. And k is also 0 to n, right? And of course, in this case, there's a way trivial take or leave, or keep or leave, or remove, or something like this. And maybe there's like another case, depending on how you want to write the removal, because there are two removal cases. But still, this is going to be an obvious n cubed, because that's just the number of states. Number of possible inputs, right? So now we have to be a little bit smarter. Even if the n cube, it's going to be n cube over 2, just because right is left to n or whatever. But still, n cubed where n is 1,000 can be too slow. So so how do we approach this? Huh. Because ideally, we do want to get it down to n squared in some way, right? And the question is, can we get rid of one of these dimensions? And because it is a removal, not because if you could change any character, that makes it obviously way easier. But a removal means that it's going to be shifting, so it's going to be a little bit tricky. Huh. Not gonna lie, I don't have an immediate thing for this one yet. I think for dynamic programming problems like this, and it's not always going to be the case, I find it kind of, and a lot of times I try to visualize what happens and then optimize the visualization in my head before coding it, which, sometimes I'm able to, and sometimes I'm not. So in those cases, I will try to write out this thing first. So let's write it out. We don't have to worry about the base case just yet because, I don't know, I mean, base case is pretty straightforward. But if keep, so basically if s of left is equal to s of right, then we can now go to, and maybe we can just skip ahead with is routed, left plus 1, right minus 1, we keep the same k, then we return true, right? Otherwise, then now we can return is routed, and for memorization, we have to kind of play around this a little bit, but we can either remove left or remove right? And of course, there is a, there is some edge cases with make sure the k is greater than 1 or greater than equal to 1 or something like that, but this is going to be the general structure. I mean, in the same idea that we talked about on the daily dynamic programming problem on day 29 or whatever it is, you can immediately get, if you do an optimization, you can immediately get rid of the k in terms of space, but that's still going to be n cubed in terms of the complexity. I think another way that I think, okay, I see that's cute, that's clever, because another thing that I was thinking of a little bit slowly is that maybe we don't need k as a parameter, right? Maybe we can change the problem, and this is something that clearly I do not do often enough because I'm a little bit slow on it. But the way that I would think about it is, instead of is valid given k, is that we could maybe do min valid. All right, so what is min valid? Min valid is that, okay, left is equal to 0 to n, right is equal to 0 to n. Again, technically this is from left to n, but okay. Yeah, and now if we don't have k as an input, then we just have n squared input, which obviously is good enough. But then the idea here is, what is the minimum deletion to make palindrome valid, right? And in this case, obviously, if you're able to have a path to calculate the minimal deletion, then now that is the optimal path. And if you have the optimal path, you can see if you can remove at most k character from it. So that's basically, yeah, I mean, I think this is actually pretty what we want to do, right? So yeah, so then now we can write something which is very similar, right? So now best is equal to infinity, so you can remove everything. I guess technically it doesn't have to be infinity, it could just be like right minus left plus 1 or something like this. But yeah, if they're the same, then now best is equal to min, best, min valid, left plus 1, right minus 1, right? Now if they're different, so this is the keep part, as we did similarly last time. The removal part is going to be, you can remove if, oh, I guess now we don't need the if k is greater less than 1. But yeah, removal is just best min valid of left plus 1. So we remove the left, is this plus 1. And then you can also remove it from the right, right? So left, right minus 1. And of course, this may even be the true even if they are the same, though I don't know if you would ever, in this particular case, do that. I mean, in some cases, yeah. And then now we just have to do min valid of 0 and minus 1, and whether that is equal to or greater than or equal to k, right? And that should be good enough. I mean, I have to fill in some more. This is not done, but the idea is going to be right. So what's base case, right? So if we have 0 or 1 characters, then we're done. So we return 0 more deletions. Actually, I think that's pretty good. And yeah, and this looks good. Huh. I mean, I guess I've done this before, so I don't remember it. So I guess, like, but otherwise I'm impressed with myself, I guess, because it's always nice to kind of have a little bit of a challenge, and then you figure it out, and it's just like one insight, really, right? But yeah, all right. Yeah. So now, of course, regular dynamic programming stuff that I always do, which is to say that we for every same input, these two and the s, of course. Oops, where did s go? You always get the same output. So let's do the math, right? Or let's save it down. I don't know why I said do the math. What am I doing? Something like this, right? And then now we can cache, right? And I said this in the other video as well, but I guess I'll repeat it for whatever reasons. But the reason why I have two caches is because I think this is just a easier way to write self-documenting code. If you're smart, or if you are like a little bit more advanced, doesn't have to be smart, then you can write it however you like. The way that I write, the reason why I write it this way is just because it's more self-explanatory. Ooh. Did I have a weird thing? It should be inclusive. Huh. Dong. Maybe I'm wrong. It's always sad to look back and you're like, I have more wrong answers than last time. But why is this wrong? Did I messed up some indexing? Huh. So I returned this as true, but this is false. Why is it false? Well, how did I get true? I guess it's probably you're supposed to return. Do I have an off by one? Maybe I have an off by one. If you have one character left, should be right. Where we're going in, we're in. Man, yikes. Left -1. Yep. We move the right. Left, right. Yep. Huh. I am stumped, to be honest. It thinks that you can do this in. How come this is not printing anything? Did he print for the other stuff? What is going on here? Why is this not printing anything? Huh? Am I being a dumbo? I mean, I am, but... Oh, I am dumb. How did this pass the first two cases? I just have a sign wrong. But how does this pass the first two cases? It doesn't even like... Yeah, I don't even have the... Oh, wow. Sometimes... I guess it's just because these two answers are true. That is kind of... Okay, fine. Sometimes you're lucky in an unlucky way. I was like, how does this not print anything? Okay. I mean, the idea is fundamentally, I guess I just kind of rushed through the base case. I mean, the idea is obviously right now that we submitted and it's passed, but I have no doubt about the idea. But I guess implementation and getting the sign right, whoops. But yeah, what I meant to say is that, if there's 0 and 1 characters, this is good. But of course, left is always going to be less than right. So this was always returning 0. But I guess we never had a force case for some reason, and yeah, I guess it just kind of returned true trivially. Whoopsie daisies. But yeah, I mean, I think this, O of n squared is the number of inputs. Each input takes O of 1 work because we only do at most 3 recursion, but they all lookup states. Yeah. That's what I have for this one, though. Let me know what you think. I think the big observation, obviously, is that you can transform this into a minimum problem or get min problem. I think that for me, it took a couple of minutes, as you saw, and then I'm doing this live. Did I do it last time? Yeah, I guess eventually I did it last time. I don't know, huh? Actually, I guess even with the K left, it worked. That's actually, I think that's just weak test cases. But I was able to optimize it away last time too. So I guess that's pretty good. That was like a year ago. But this time I did it without the. Well, I guess I did type it out, but I knew that it was. I thought I was going to time out. But yeah, that's all I have for this one. Let me know what you think. Happy holidays. Happy New Year soon. Stay good. Stay healthy. To good mental health. I'll see y'all later and take care. Bye bye.